present temperature with the surrounding air. I mean, we can't do it, but this is for our understanding, because oceanographers and meteorologists, they send their balloons up to understand that, and that is what we receive on the weather pack. So if the air parcel is warmer than its surrounding, it's a gas, it expands, becomes less dense, less it becomes less in mass, that is lighter than the surrounding, it will start there, like a hot air balloon, and that is what is the bottom line for creating of bad weather, because the low pressure gets created. And if air parcel is cooler than the surrounding, it is heavier because it is dense. And if that parcel of air is upstairs, it will become heavier, it will start sinking. And therefore, it leads to good weather because the pressure at the surface will increase. These are the basic rules that we follow. Very simple, we are only concerned with bad weather. Good weather, to yaar, why should we complain about it, right? So warm temperature, hot air, expansion, less dense, lighter, starts to rise, causes havoc. The bottom line. Now, this is the diagram that you have to understand and just practice. Keep looking at it. I will be asking one or two small questions. Along the x-axis, the temperature in degrees Celsius. Suppose this is 0, let's assume this is 30 degrees centigrade plus. So that means along the x-axis, as the arrow shows, the temperature is rising. This is y-axis 0, this is the altitude. It could be meters, kilometers. It's not important for the point of discussion. Now, D means the dry air. DSLR, 10 degrees Celsius per kilometer rise is applicable here. S is the saturated air, and this is taken an arbitrary value of the present condition environment. Look at the figure. Which air has cooled the maximum for this altitude? Let this altitude be X kilometers above the surface. Look at the thing which has cooled the maximum out of D, E, and S.
Sir, DLR.
The dry air has cooled maximum. Why? Because if we say, let's say this is 30 degrees. From 30 degrees, if this is maybe 10 degrees, that means it has cooled 20 degrees at this height. Very correct answer. Saturated air, if this is 30, if this is, let's say 20 degrees, it has only cooled for 10 degrees. It has temperature drop here has been 20 degrees, temperature drop here has been 10 degrees. Here you can say, okay, about 8-9 degrees of temperature drop. This is an ideal situation, that is number one, where your ELR is somewhere between the dry air and the saturated air, which are the fixed values. So what we see from the figure, as we go toward the right, the temperature is higher. So if we take this dotted line as the reference point, any area toward the right of it is a warm side because the temperature here is warmer. Are you with me?
Yes, sir.
Because for simple reason, the temperature here is less, here it is warm. And so therefore, the rule is the area which is to the right of the environmental lapse rate is a warm side. Similarly, the area toward the left of the dotted line, the environmental lapse rate, is the cold side because the temperature here is, this temperature is colder than this. So you have to, the other rules that you have to remember, any area that is on the graph between altitude on the y-axis and temperature on the x-axis, any area toward the right-hand side of the environmental lapse rate shown dotted is always the warm side. And therefore, the area on the left side of the dotted ELR is always the cool side. Now, this is what I said. An air parcel line plotting to the right of ELR indicates unstable condition because that air is warmer, expands, rises, creates havoc. An air parcel line plotting to the left of ELR is stable because it is on the colder side. Are you with me till here? Are you with me?
Yes, sir. Yes.
Okay. Now, when we talk about absolute stability, absolute instability, and neutral stability, first of all, this is the extreme case. Most of the time, in reality, this is what we see. ELR is somewhere between the DLR and SALR. Okay. The word absolute means both the lines plotting the DALR and SALR are on either the left-hand side or the right-hand side of the dotted ELR. When both the SALR line and DALR line are towards one side only, either to the left-hand side or the right-hand side of the ELR, we talk about absolute stability or absolute instability. So it is never the absolute condition. This is the ideal or worst case scenario. When we take about absolute stability, where both DALR and SALR are on the left-hand side of ELR, so now they are on the colder side or warmer side.
Colder side, sir, colder.
Very good, very good. So the notation is DALR is greater than SALR is greater than SALR. We are talking about absolute stability because it is on the colder side. The air will not rise as quickly as in case of warm conditions. Similarly, absolute instability would be when both these lines are on the warm side, which is the right side. The ELR is greater than DLR and greater than SALR. That means we are in a bad situation. Extreme case. They both are in the warm side. Are you with me?
Yes.
Have you copied this? Guys, after all this, go ahead.
सर पहले तो हमने ये पढ़ा था ना सर ELR is less than DLR तो एयर कूल रहेगी और ELR is actual atmosphere first.
Correct, correct. What I'm trying to say is, come back to this. This is your ideal situation diagram, 50-50. And what we have seen, on the left-hand side of this plotting, the air will always be cooler. That means air is dense. They are cold conditions. Colder conditions means that the pressure is high pressure area. We are talking about the good weather.
Good weather, sir.
Exactly. The warm side is on the right hand side. That means whatever the condition of the system, the air is going to continuously rise and create havoc.
Low pressure.
So that is what is the absolute means, the extreme level of scenario. Both the lines, whether it is now, there are two elements. There are two elements. One is cold air, that is to do with the temperature. Other element is the dry or wet. Okay, so when we take absolute stability, both DALR and SALR are going to be on the colder side, because it is on the left hand side of the plotted ELR. At the surface itself, the air is cold. It is going not to be so quickly rising as the warm air. So there is no question of a low pressure being created. The weather will be good. Whereas on the absolute instability is when the air is continuously rising, because it is on the warm side, whether it is wet, whether it is dry, that is immaterial. It is on the warm side of the environmental condition. That means the low pressure area is being continuously forming. The air is rising. There are clouds continuously forming. We are talking about bad weather. And when it is taken as in between, the chances are 50-50. Whether the weather will be good or bad, it depends on the frictional or the other atmospheric condition 1-2 kilometers above that the airplane pilots have to deal with it. We don't have to deal with it. When the ELR is in between, it is greater than ELR, which is greater than SALR. It depends. That is, you can have wind force 0, see like a mirror, or they can be depending upon the turbulence up, which is preventing the rise of air. You can have normal conditions also, or you can have bad conditions. This is what is conditional or neutral stability. This is absolute instability. This is absolute stability. This is the diagram you have to practice. Have the notation. Write in the short notes. You are clear. The point is, have you understood this?
Yes, sir.
Yes.
Yes, sir.
So, this is how an approximate idea with regard to temperature that I've given. Let's say this is the air is dry, relative humidity is very less, it is rising slowly, no bad weather, but evaporation to hota hi hai. At this point, the dew point temperature is reached. That means the crystals will start forming, condensation level, so the clouds start forming here. Now, the air will rise because it has become completely saturated. If there is further rise, it will be at the rate of SALR. The cloud cover will continue, it will form, the cloud level will be larger rather than this thin. And at this point, no further cloud formation is there, so the size of the cloud will be pretty large. This is just an indication. Practically, I've put some clouds in between. This is stable air, that is cold. Unstable air, warm. Lapse rate is shallow, 5 degrees. Lapse rate is very steep, 10 degrees. Cloud type, we have not yet done the cloud. I'll come back to it. Precipitation, drizzle, but here you're going to have showers. Visibility, poor to low. Why? Can anybody tell me? Because we are talking about stable air, we are talking about colder air temperature. Yes or no?
Air is denser, sir. Denser air.
Yes. And
As
it
it
is a
is coming
cold
down
air.
here.
Exactly. So visibility can be poor. Unstable air, low pressure area will create a strong wind, but it does not affect the visibility. Only if there are very, very strong showers, the visibility suddenly reduces. Stable air, winds are steady, nice wind, force 3 or 4. Unstable, rising quickly. We are talking about strong gusting winds, sudden increase in wind. Turbulence, smooth condition. They can be severe. This indicates our stability and instability in the atmosphere. Have you understood this main concept?
Yes, sir.
Yes, sir.
Adiabatic changes we have done now.
सर
go ahead.
अगर सर आपने अभी जो डायग्राम दिखाया था ना वो क्लाउड फॉर्मेशन हो रहा था सर उसको दिखाएंगे दोबारा से
Sure. बोलो.
सर जब सर ये कोई एयर पार्सल ड्राई एयर पार्सल जब ऊपर जा रहा है तो सर वो डीएलआर की तरफ से मतलब जा रहा है और जब वो उसका एक लेवल आएगा कंडेंसेशन लेवल तो वहां पे उसकी रिलेटिव ह्यूमिडिटी 100% मतलब हो जाएगी
Almost, हाँ.
ऑलमोस्ट
close.
100%.
Correct.
उसके बाद फिर वो मतलब बन जाएगा एसएलआर की मतलब उस पे जाएगा रेट पे.
Excellent, क्योंकि वो एयर वहां पे हैवी हो गई है. करेक्ट, हैवी हो गई है. अगर ज्यादा हैवी हो गई है तो it will start falling down as rain. But many times you have C7 also, it is cloudy. So air at that level, if it is continues to rise because it has become moist and dense, it will cool at the rate of SALR.
SALR.
And ये भी नहीं कि हाँ
सर लेकिन ये फिर ये कहाँ पे जाके मतलब से ये रुकेगी ये एसएलआर कहाँ पे जाके मतलब रुकता है ये?
एग्जैक्टली कि वहां पे when this temperature SALR का अभी के हिसाब से यहाँ पे इतना कूल हो गया है and the surrounding temperature is absolutely same, it will stop rising.
Okay, sir.
Because the rule, we compare the present air with the surrounding and not the other way around. Repeat?
Yes, sir.
Now